Welcome to part 3 of trigonometric ratio. So we're going to be doing example number 1 for today. So remember what I told you. I said every time you're dealing with this, make sure you write saw, car, tor. It will help you remember your trig definitions, okay? But before you can go anywhere, make sure you identify your side. Remember what I told you. I said from your 90-degree angle to your theta, or from your theta to your 90-degree angle, you have an adjacent side. Your 90 degrees will face your hypotenuse, and the remaining side will be your opposite. And remember, we're finding all of this in terms of theta. We are finding all of these things in terms of our theta right here. From theta to 90 degrees adjacent, 90 degrees faces our hypotenuse, and the remaining side will be our opposite. Okay. Now, example number 1. It says in triangle ABC, AB is equals to 5 centimeter, BC is equal to 13 centimeter, and AC is equals to 12 centimeter, and angle number C is equals to theta. But also notice that angle number B is equals to beta, because we're about to solve also this question. It will be very helpful. Okay, so we have identified all of our sides in terms of our theta. Okay, so now question 1, it says write the value of sine theta. Okay, remember what I told you. The value of sine of theta will be equals to, using your SOHCAHTOA. Your SOHCAHTOA tells you that sine theta is equals to opposite over hypotenuse. So you have your opposite over your hypotenuse. Your hypotenuse, which will be equals to, you already identified all of your sides in terms of theta. So you already know which one is adjacent, which one is opposite, which one is hypotenuse. So your opposite, you have 5 centimeters. So it will be 5 over your hypotenuse, which is 13. And just like that, you have found your sine theta. But they were not asking for sine theta alone. They also asked for cos theta and also tan theta. So we're going to do them all. Remember, cos theta, we have the definition from our SOHCAHTOA right there. We remember that it's equals to adjacent over hypotenuse. So you check your triangle. Which one is your adjacent side? Your adjacent side, you discover that it's 12, and your hypotenuse side is equals to 30. Okay. Now for tan of theta, according to SOHCAHTOA, it's opposite over adjacent. So we'll have our opposite over our adjacent side. Okay, we discovered that our opposite in terms of theta is equals to 5, and our adjacent was equals to 12, and just like that, we have found your first answers. Okay, so it's very, very important for you to know that, because it gets more difficult than this. Okay, let me just rub off some of this old information, because it's about to change. It's about to change, and we also need to change with it. It's about to change, and we also need to change with it. Look at question number B. It says write down the value of sine beta, cos beta, and tan beta. Okay, now you must look for your angles in terms of your beta. So from your beta to your 90 degrees becomes your adjacent side, and from your 90 degrees straight to the side that is facing your 90 degrees is our hypotenuse, and the remaining side will be your opposite. You'll notice that there will be a change of sides when you're using a different angle. In our case, where we discover that now there's change of sides. Okay, so sine theta, according to SOHCAHTOA, sine, the definition of sine, according to SOHCAHTOA, we just discovered that sine is equals to opposite over hypotenuse. So we're going to write down our definition, which is equals to opposite over hypotenuse, just like that. Then what's our opposite in terms of beta? In terms of beta is equals to, our opposite is equals to 12 over our hypotenuse is equals to 13. Okay, now we're going to find for cos beta. What's our definition for cos? Our definition for cos, according to SOHCAHTOA, cos is equals to adjacent over hypotenuse. So we're going to have our adjacent side, adjacent over hypotenuse. Okay, we have already discovered our sides, or found our sides. The adjacent side is equals to 5, and the hypotenuse side is equals to 13. Okay, now we're going to find for tan of beta, which is equals to according. Remember, we're searching for all of these things according to our SOHCAHTOA. Tan is equals to opposite over adjacent. So that's what we're gonna have. We are gonna have our opposite over adjacent side, which is equals to our opposite was 12 and our adjacent side was 5, just like that, and we would have found all of the angles that they are looking for. Catch me in part number 4, where we'll be doing another example which is a little bit more complicated and has more than one triangle. Good luck.